Hello everyone, this is Physics 101 and this lesson will tackle about heat calorimetry and thermal expansion. So let's first start with defining temperature. So temperature is the degree of hotness or coldness of a body. So temperature is also called the average value or simply the average of the individual kinetic energy of the molecules in random motion. So for example, I have here a sample of gas and it has air molecules inside. So all these molecules have different speeds. Some may be faster, some may be slower. And if you were to take the average speed of all the individual molecules inside this container of gas, that is what we defined that is what we observe as the macroscopic temperature. So macroscopic meaning that it defines the value for all the molecules. So the more energetic these molecules are, the higher the temperature will be. So next we define a quantity called internal energy. So internal energy is the energy from the kinetic and potential it's the energy from the kinetic and potential energies associated with random motion of the molecules. So you can think of it as related to the temperature of an object. So when an object is much hotter, it will have a higher internal energy. So next we define a quantity called heat. So heat is transferred energy. Take note, transferred energy. Wrong spelling. And is symbolized by Q. So what does it mean for heat to be a transferred energy? So for example, we have here a system of a hot coffee and an iced tea, a cold iced tea. So let's define the temperatures in this system. So we have here temperature of the environment, temperature of the coffee, which is hot, and the temperature of the iced tea, which is called TC. Now all the energies associated in this system should be conserved according to the conservation of energy. So what we mean by transferred energy is that by the second law of thermodynamics, energy will flow from this hot object to the cold one. So that amount of energy is called Q. So Q is equal to so we should define it first as proportional to the temperature difference between two bodies. So it's not the actual energy of these individual bodies, but it is the transferred energy from a hot object to a cold one. So heat is measured in calories. So heat and 1 calorie is equal to 1 calorie is equal to 4.1868 joules. So heat is in units of energy, but it's not the actual internal energy of the objects. This is only a way of quantifying the transferred energy.